They told us these engines were dead, obsolete, relics of a dirtier time, so we believed them. We traded in our old outboards for shiny new machines packed with sensors, computers, and price tags we'd never seen before. And for a while, it made sense. But now, something strange is happening on docks across America. Boat owners are hunting for the engines they were told to throw away. Mechanics are turning down brand new motors, and prices on 20-year-old outboards are climbing faster than the machines that replaced them. The industry promised us the future. Instead, they handed us repair bills we can't afford and problems we can't fix. This is the story they don't want you to hear. To understand how we got here, we need to go back to a moment when the entire marine industry changed direction. It was 2006, and the Environmental Protection Agency had just tightened emission standards for outboard motors. The rules weren't unreasonable. Boat engines had been dumping unburned fuel into waterways for decades, and something had to change. The manufacturers responded with a unified message. The two-stroke engine was finished. The future belonged to four strokes. And the marketing campaign that followed was relentless. Every boat show, every dealer showroom, every glossy magazine ad carried the same promise. Four-stroke outboards were cleaner. They were quieter. They sipped fuel instead of gulping it. They idled like sewing machines and never left an oil slick behind the transom. For a lot of boat owners, it sounded like progress. And in many ways, it was. The engineering achievements were real. A well-designed four-stroke outboard could deliver 20 to 30% better fuel economy than a comparable two-stroke. Hydrocarbon emissions dropped dramatically. You could hold a conversation at idle without shouting. Trolling for fish became a quieter, more refined experience. These weren't marketing fantasies. These were measurable improvements. By 2010, the transition was nearly complete. Yamaha, Mercury, Honda, Suzuki, every major manufacturer had committed to four-stroke dominance. Dealers stopped ordering two-strokes. Service departments stopped training technicians on them. The message to consumers was clear and unanimous. Upgrade now or get left behind with yesterday's technology. The numbers told the story. In 2006, four-stroke outboards represented about 45% of new sales in North America. By 2015, that number had climbed to 89%. And in 2020, Evinrude, the last major manufacturer still producing two strokes for the American market, shut down production entirely after more than a century in business. It looked like the debate was over. The two-stroke engine, the motor that had powered recreational boating since the 1950s, was officially obsolete. Except it wasn't. Because here's what the industry didn't talk about during those years of aggressive marketing. The two-stroke engine wasn't just some primitive relic waiting to be replaced. It was a design philosophy that had dominated marine propulsion for 8 decades, and it had done so for very good reasons. The fundamental advantage of a two-stroke is elegance through simplicity. A two-stroke engine produces power on every revolution of the crankshaft. A four-stroke produces power on every other revolution. That basic difference means a two-stroke can generate the same horsepower with roughly half the moving parts. Fewer parts means less weight. A 150 horsepower two-stroke might weigh 75 to 100 pounds less than its four-stroke equivalent. On a small boat, that difference changes everything. How the hull sits in the water, how it accelerates, how much fuel it burns getting on plane. Fewer parts also means less complexity. A carburetor on a traditional two-stroke could be rebuilt by any competent mechanic with a basic toolkit and a service manual. Many boat owners did it themselves, in their driveways, on a Saturday afternoon. The relationship between operator and machine was direct and understandable. And then there was durability. Two-strokes earned their reputation in the harshest conditions on Earth. Commercial fishing in Alaska, shrimping in the Gulf, charter operations in saltwater that destroys lesser equipment. Operators ran these engines thousands of hours, rebuilt them when necessary, and ran them thousands more. The design wasn't just simple, it was proven. But the industry had moved on. The two-stroke was declared dead. And for a few years, That declaration seemed permanent. Then the bills started coming due. The first sign of trouble wasn't mechanical failure, it was sticker shock. Between 2019 and 2024, outboard motor prices increased faster than at any point in the industry's history. A Mercury Verado 300 that sold for $24,500 in 2019 climbed past $32,000 by 2024. Yamaha's F300 jumped from $22,800 to nearly $30,000. Suzuki's DF300 followed the same trajectory, a 31% increase in just 5 years. For boat owners running multiple engines, the math became brutal. A triple outboard setup that cost $72,000 in 2019 now ran past $95,000. Before rigging, controls, or installation, the boat itself might cost less than the power hanging off the transom. Several forces drove the surge. The COVID-era boom in boat sales created unprecedented demand between 2020 and 2022. Supply chains buckled under pressure, especially for precision components manufactured overseas. Aluminum prices spiked. Rare earth elements used in electronics became harder to source, and modern four-strokes had become increasingly dependent on sophisticated sensor systems and computer controls that added cost at every level of production. But price wasn't the only problem. Complexity was becoming its own crisis. A modern four-stroke outboard is an engineering marvel. It has to be, to meet emission standards while delivering the horsepower boat owners demand. But that sophistication comes with consequences. A typical four-stroke now contains 15 to 25 sensors, monitoring everything from oil pressure to exhaust temperature to throttle position. Proprietary engine control units process data streams in real time. Digital throttle and shift systems have replaced mechanical cables on many models, eliminating the backup systems that once let stranded boaters limp home. When these systems work, they work beautifully. When they fail expensively. Service bulletins and owner forums began documenting patterns that manufacturers preferred not to discuss. Mercury issued technical service bulletins for oil separator problems on certain Verado models produced between 2018 and 2021. Yamaha F300 owners reported fuel injector failures requiring repair bills exceeding $3,500. Suzuki DF250 units developed intermittent ECU glitches that caused unexplained shutdowns, problems that could only be diagnosed with factory equipment and often required $2,800 module replacements. The mechanics who worked on these engines every day saw the shift most clearly. One technician in Louisiana, a man who'd been turning wrenches on outboards for 3 decades, put it simply. He said he used to fix engines with a Chilton manual and a socket set. Now he had $45,000 in diagnostic equipment, and half the time he still had to call the factory for guidance. The problem wasn't incompetence, it was architecture. Modern four-strokes were designed to be serviced by authorized dealers using proprietary tools. That model works fine in a car dealership. On a boat ramp in rural Alaska or a commercial dock in the Florida Keys, it creates a dependency that working boaters cannot afford. Water pump impeller replacement, one of the most routine maintenance tasks in outboard ownership, illustrates the divide. On a traditional two-stroke, it's an $85 parts job that a handy owner can complete in a couple of hours. On certain modern four-strokes, the same repair can run $450 to $700 because dealer service is required to clear fault codes and reset system parameters after reassembly. Boat owners began sharing these experiences online. They compared invoices. They documented repair timelines. They asked questions the marketing brochures never anticipated. And slowly, a calculation started forming in their minds. A dangerous question that threatened the entire foundation of the four-stroke revolution. What if the engines they threw away were actually better? The used outboard market is not supposed to work this way. Engines are depreciating assets. You buy them new, you use them, they lose value. That's how it's always been. until it wasn't. Starting around 2021, something unprecedented began appearing in the sales data. Late-model two-stroke outboards, engines that were supposedly obsolete, started appreciating in value, not holding steady, actually increasing. A 2012 Evinrude E-Tech 250 that sold for $5,500 in 2021 was fetching $9,800 by 2024. A 2010 Mercury Optimax 225 climbed from $4,800 to $8,200 over the same period. And the Yamaha HPDI 200 from 2008, an engine more than 15 years old, doubled in price, jumping from $3,200 to $6,500. These weren't collector items being hoarded by enthusiasts. These were working outboards, being bought by practical boat owners who had done the math and reached a conclusion the industry refused to acknowledge. The commercial waterfront figured it out first. These are operators who don't care about marketing or brand prestige. They care about one thing: getting on the water, doing the job, and coming home. Downtime isn't an inconvenience for them. It's lost income. In Alaska, commercial salmon fishermen started stockpiling Yamaha HPDI units, refusing to convert their boats to four-stroke power. In Louisiana, shrimpers who had run Mercury Optimax engines for years began rebuilding powerheads rather than upgrading to newer technology. Charter captains in the Florida Keys actively sought out low-hour Evinrude E-Techs to repower proven hulls, even as dealers tried to sell them brand new equipment. The reasoning was consistent across every dock and harbor. A charter captain in the Keys explained it bluntly. He said he doesn't need Bluetooth. He doesn't need a touchscreen. He needs an engine that starts when it's 28 degrees outside, runs hard all day, and can be fixed without waiting 2 weeks for a dealer appointment. A commercial fisherman in Kodiak echoed the same logic. When his old two-stroke had a problem, his captain could diagnose it, order parts, and complete repairs at the dock. When a four-stroke throws a fault code, the boat sits idle until a factory-trained technician becomes available. In a seasonal fishery, that delay can mean the difference between profit and loss. The YouTube mechanic community amplified these voices. Independent technicians began posting detailed comparisons, repair costs, parts availability, compression tests on high-hour engines. The footage was unglamorous, but devastating. 20-year-old two-strokes showing better compression numbers than 5-year-old four-strokes. $6,000 four-stroke repairs that would have cost $800 on a comparable two-stroke. Diagnostic investigations revealing that certain four-stroke replacement parts had already been discontinued. The total cost of ownership picture came into focus. For a boat owner running 150 hours per year over a decade, a modern four-stroke might save $315 annually in fuel. But it cost nearly $1,500 more per year in purchase price, maintenance, repairs, and depreciation. Over 10 years, the supposedly obsolete two-stroke wasn't just competitive, it was almost $15,000 cheaper to own. The fuel efficiency argument, the core promise of the four-stroke revolution, had been real. But it had also been incomplete. The marketing highlighted one number while hiding dozens of others. For years, the industry told boat owners that two-strokes were dirty, unreliable, and economically foolish. They were told to upgrade or be left behind. They were told the future had arrived. Now, invoice by invoice and repair bill by repair bill, those same boat owners were discovering the truth. They hadn't purchased progress. They had purchased complexity. And complexity has a price that never stops compounding. Understanding how we arrived at this moment requires looking beyond engines and into boardrooms. The shift from two-stroke to four-stroke wasn't simply a story of better technology replacing worse technology. It was a convergence of regulation, economics, and corporate strategy that reshaped an entire industry, sometimes for good reasons, sometimes for profitable ones. The regulatory pressure was real and in many ways justified. Traditional carbureted two-strokes dumped as much as 30% of their fuel oil mixture directly into the water, unburned. Lakes and rivers showed the damage. The EPA's tightening emission standards in 2006 and 2010 addressed a genuine environmental problem. That part of the story is defensible. But here's what gets lost in the narrative. The regulations didn't mandate four-stroke engines. They mandated emissions levels. And by the mid-2000s, several manufacturers had proven that direct injection two-strokes could meet those standards. The Evinrude E-Tech passed EPA 2010 requirements with room to spare. The Mercury Optimax achieved similar compliance. These weren't dirty engines clinging to outdated technology. They were sophisticated machines that solved the emissions problem without abandoning the fundamental advantages of two-stroke design. Yet the industry moved away from them anyway. And the reasons had less to do with environmental responsibility than with business models. Four-stroke outboards aren't just cleaner, they're more profitable. The math is straightforward. More components mean more parts to sell. Proprietary engine management systems require proprietary diagnostic tools. Dealer-dependent service networks ensure that repair revenue flows through authorized channels. A four-stroke service department generates roughly 40% higher margins than the same department working on two strokes. The shift also accelerated replacement cycles. A well-maintained two-stroke, especially the late-generation direct injection models, could run 3,000 hours or more before requiring major work. Commercial operators routinely exceeded those numbers. Four strokes, with their tighter tolerances and sensor-dependent systems, often showed their age much sooner. Not because the engineering was poor, but because complexity compounds. More systems mean more potential failure points. More electronics mean more sensitivity to voltage fluctuations, corrosion, and the harsh realities of marine environments. Manufacturers understood this calculus. A customer who buys an engine that lasts 20 years is less valuable than a customer who buys an engine that lasts 10. This isn't conspiracy, it's accounting. The consumer trap was constructed methodically. Dealers stopped stocking two-strokes because manufacturers stopped incentivizing them. Mechanics stopped learning two-stroke systems because training programs focused exclusively on four-stroke technology. Marine lending programs sometimes refused financing on boats powered by older two-stroke engines, even when those engines were mechanically sound. The industry didn't just promote four strokes, it systematically eliminated the alternatives. And here's the part manufacturers truly don't want discussed. The generation of mechanics who understood two-stroke technology is aging out of the workforce. The institutional knowledge that kept these engines running, the tricks, the troubleshooting sequences, the understanding of how these machines actually behave, is disappearing. Diagnostic tools for older systems are no longer manufactured. Parts suppliers are consolidating or closing. Every year, the knowledge gap widens, and as it widens, the remaining two strokes that still run become more valuable, not because demand is irrational, but because supply is finite and shrinking. The question that haunts this entire story is simple. If four strokes are genuinely superior in every meaningful way, why are the professionals, the commercial fishermen, the charter operators, the people whose livelihoods depend on absolute reliability, actively hunting for 20-year-old two-strokes instead of buying new equipment? The industry has an answer for that question. But boat owners have stopped believing it. So where does this leave us? The honest answer is somewhere between a reckoning and a crossroads. The two strokes winning in today's market won't be available forever. No major manufacturer produces them for the North American market anymore. The remaining inventory is finite, aging 1 year at a time. Aftermarket parts suppliers depend on overseas manufacturing that could shift or disappear. The mechanics who truly understand these engines are retiring, taking decades of knowledge with them. This isn't a permanent solution. It's a window, and that window is closing. The boat owners snapping up clean E-Techs and low-hour Optimax engines understand this. They're not making a statement about the past. They're making a calculated bet about the next 10 to 15 years. A bet that the engines they can fix themselves will outlast the engines that require dealer intervention for every fault code. Some signs suggest the industry is listening, even if it won't admit the reason why. Mercury's newer V6 and V8 four-stroke platforms show simplified architecture compared to earlier generations. Yamaha's offshore-focused designs have begun emphasizing serviceability and reduced sensor dependency. Right-to-repair legislation, long ignored in the marine sector, is gaining traction in state legislatures, pushed by coalitions of boat owners who are tired of being locked out of their own equipment. These are small shifts, but they matter. They suggest that manufacturers understand, at least internally, that the complexity curve bent too far, too fast. And then there's the larger question looming on the horizon. Electric propulsion is coming to the marine industry. Companies like Evoy, Pure Watercraft, and Mercury's own Avator division are developing battery-powered outboards that promise zero emissions, silent operation, and maintenance requirements that make even the simplest two-stroke look complicated. For inland lakes, small boats, and short-range applications, electric power is already viable. But for offshore fishing, commercial operations, and blue water cruising, battery limitations remain severe. Energy density simply isn't there yet. A center console running 70 miles offshore needs fuel capacity that current battery technology cannot deliver at acceptable weight. Combustion engines, whether two-stroke or four-stroke, will remain the backbone of serious boating through at least 2030 and likely beyond. The question is, what kind of combustion engines, designed with what philosophy, and serving whose interests? This story was never really about two-strokes versus four-strokes. That framing misses the point. This is a story about what happens when an industry mistakes complexity for progress and price for value. It's about the gap between what marketing departments promise and what service departments deliver. It's about boat owners who trusted expert consensus, spent their money accordingly, and discovered years later that the consensus was incomplete. The engineers who designed modern four-stroke outboards created remarkable machines. The power density, the emissions control, the refinement at idle. These achievements deserve respect. But the engineers who perfected late-era two-strokes created something harder to quantify. Machines that lasted. Machines that forgave mistakes. Machines that could be understood, maintained, and repaired by the people who depended on them. Both traditions deserve honesty. Both deserve recognition for what they achieved and acknowledgement of what they sacrificed. In the relentless pursuit of cleaner, quieter, smarter engines, did the marine industry lose something simpler and more durable? Something that just worked? The boat owners hunting for old two-strokes have already answered that question for themselves. The industry may eventually have to answer it too. Progress is supposed to mean moving forward. But sometimes, moving forward means remembering what worked and having the courage to ask whether we left it behind too soon. The water doesn't care what year your engine was built. It only cares whether you make it home.